Hello everyone. Today we are going to start our next topic of general navigation, which is PNR or PSR, which is point of safe return or point of no return. It is also called as radius of action, ROA, but usually we use the name PSR or PNR. Just like in critical point, PNR also has three types: theory based PNR, numerical PNR, and CX3. First, I'm going to explain to you what exactly PNR is and how it is different from critical point. Then we are going to study the notes. So let's begin. So if you remember critical point, it is when you move from point A to point B, from destination A to destination B, and the point at which the time to travel to either A or B is same is called as the critical point. This is what we studied. Now PNR or PSR, which is the point of safe return or point of no return, it is the maximum distance from point A to point B when we are traveling. It is the maximum distance that the aircraft can travel and still return to its base safely without risking fuel exhaustion. I will repeat: PNR, point of safe return, which is PSR, and point of no return, which is PNR, is the maximum distance that the aircraft can travel and return to its base safely within its endurance is called PNR. Within its safe endurance. Now, what is safe endurance? I have told you in the video of critical point also. It is how long the aircraft can fly safely without risking fuel exhaustion. Do not worry, I will repeat it again if you have not understood. I will compare it with critical point for better understanding. So critical point was when you were traveling from point A to point B, and the point at which the time to reach either base A or base B was equal. Your departure aerodrome and destination aerodrome time was same. That was your critical point. But our point of safe return is when you're traveling from place A to place B, and all of a sudden A is your departure aerodrome and B is your destination aerodrome. So you were moving from place A to place B, and some situation occurred at place B. For example, the aerodrome shut down, or the visibility was low, there was fog, there was thunderstorm, CB clouds, any of these things. So your destination aerodrome shut down, and your alternate aerodrome, for example, this is your alternate aerodrome or this is your alternate aerodrome, they are also not available. So now now the only option left for you is to return to your base, which is the departure aerodrome, and in this case it is A. So the maximum distance that you can travel and then return to this base safely in so and so conditions without, this is a very major part, without risking fuel exhaustion, or you can say that the maximum distance you can fly out and then return to base safely within the safe endurance of the aircraft is called the point of safe return. I hope I've made it clear to you. So like I told you, in critical point you have to draw this diagram, that this is A, B, this is your CP, this is your reduced speed home, this is your reduced speed outbound, OH. Now you have to draw a diagram in PNR or PSR also, and this is the diagram that you will be using in all of your numericals. So learn these diagrams, understand these diagrams really well. So this is the basic diagram that you would be using in CP, and the diagram I would be drawing now is the diagram you will be drawing in PNR or PSR questions. So this is your A to B. There are two kinds of speed here. In critical point, we studied three kinds of speed. One was reduce speed home, reduce speed out, and G full. This was CP. This is PNR or PSR. In these questions, we use two kinds of speeds. H and O, they are depicted by H is reduced speed homebound, just like CP, but our O here is O full. Like here we did G full, here we use O full, which is normal speed outbound. There is no reduced speed outbound, it is normal speed outbound. This is okay. So now let's put these speeds in the diagram. So normal speed outbound, when we are departing from the departure aerodrome, this is where we use our O full, which is normal speed outbound. Then we reach the PNR point. What is our PNR point? It is the maximum distance the aircraft can fly out and still return to its base within its safe endurance. Or the second definition, the maximum distance the aircraft can fly out and return to the base safely without risking fuel exhaustion. So this is our PNR point. And now when we are coming back, we come back on a reduced speed and we are coming home. So this is our H, which is our reduced speed homebound. So this is the diagram we draw for PNR questions. This is our basic diagram, and this is the diagram we would be using for all of our numerical questions. Now just like CP, PNR also have two formulas, actually three formulas. We have dPNR, which is distance to PNR, TPNR, which is our time to PNR. So our dPNR is E, which is the safe endurance, into O into H upon O plus H. This is our dPNR formula. TPNR is E into H upon O plus H. This is our time to PNR formula. And the E that we are using here is safe endurance. The formula for safe endurance is, or here we as write it, E, is fuel on board minus reserve upon fuel consumed. This is our formula for safe endurance, and it's a very important formula actually. And safe endurance we get in hours. Okay. Then we also have one more formula, which is total endurance. It is fuel on board upon fuel consumed. By this we get our total endurance. Now let's study how PNR is affected by winds like we did in critical point. So we have three kinds of winds: nil winds, headwinds, tailwinds, and crosswinds. I have explained it to you what are these kinds of winds in the critical point video, so you can check it out. So let's draw the basic diagram. Point A, which is your departure, point B, which is your destination. Here lies your PNR, which is the maximum distance you can fly out and return to base safely without risking your fuel exhaustion or within the safe endurance. This is your PNR. This remains to be your PNR in nil winds when it is still air. And in case of nil winds, which is this situation itself, PNR is at the maximum distance. As the definition suggests, that it is the maximum distance you can fly out. So, in case of nil winds, our dPNR, which is the distance to PNR, maximum. In nil winds, when you're moving from A to B, the maximum distance you can fly out and return to the base within safe endurance is your PNR. And in nil air, the PNR would be the maximum. There is no sort of winds, no headwind, no tailwind, no crosswinds affecting your PNR. So the dPNR remains to be maximum. But now in the case of headwind, tailwind and crosswinds, the dPNR will reduce. Why? Why? That is your first question. Second, when we did critical point, when there was headwind, when there was tailwind or crosswinds, then these three changed differently. But in case of PNR, they all are same. They are all reducing. So I will explain to you by two statements that CP is a function of winds and PNR is a function of fuel. So in CP, the fuel did not affect how the distance to PNR changed. But in PNR, as it is a function of fuel, and when you get headwind, tailwind or crosswinds, your fuel consumption increases. And when, it is also an important point, when your fuel consumption increases, obviously you will be traveling lesser distance. The increase in the fuel consumption reduces the distance traveled. And this is what is happening here. So as the fuel consumption in these three winds increases, the distance to PNR reduces. So earlier, when your PNR was here, in case of headwinds, tailwinds or crosswind, your PNR has shifted to here. This is your new PNR. It has shifted backwards. So what we studied is that in case of nil winds, the dPNR will be maximum. The dPNR in case of nil winds would be maximum. But in case of headwinds, tailwinds and crosswinds, our PNR will reduce. Our PNR will shift towards the departure. Okay? Now there are two more things that you have to learn. One is this only. One is about fuel consumption only, which I told you. That when the fuel consumption increases, the dPNR, the distance to PNR reduces, because now you're consuming more fuel, so your distance traveled would obviously be less. The second important point, when the fuel on board increases, the distance to PNR increases as well, which is quite obvious. When you're carrying more fuel, you can travel more distance. So now let's move on to the notes with the definition. PSR, which is the point of safe return, is the maximum distance an aircraft can fly out and still be able to return to the selected base within the safe endurance of the aircraft. Within the safe endurance of an aircraft is called point of safe return. AB, the maximum distance the aircraft can fly out and return to the selected base within the safe endurance, or the maximum distance the aircraft can fly out and return to the selected base safely without risking fuel exhaustion is called point of safe return. Then required if both the destination and the destination alternate are not available. Like I told you that due to certain situations at B, maybe the aerodrome is closed, visibility is low, there is fog, thunderstorm, CB cloud, you are not able to land at B and the alternate aerodrome is also not available, we require a PNR. Then we have time to PSR or PNR, which is our TPNR Formula is E into H upon O plus H, where E is safe endurance, H is reduced ground speed home, and O is normal ground speed out, like I told you. Let's move on to distance to PNR. Our DPNR is E into O into H upon O plus H. That is the formula for DPNR. Now, we have factors affecting the PNR. First point, the greatest distance from departure point to PNR occurs in still air. Still air means nil winds. So the greatest distance. So this is the point that we studied, that in nil winds, the PNR is maximum. Any wind component, no matter if it is headwind or tailwind, will cause the PNR to be closer to the departure point, or the distance to PNR will decrease. So in case of headwinds, tailwinds or crosswinds, the DPNR will reduce, or like we studied, the PNR will shift towards the departure. Then we have beam winds or crosswinds will also reduce the distance to PNR. One important point, if you remember in critical point when we were studying crosswinds, there the DCP was stable but TPNR had increased. But here the DPNR is decreasing and TPNR is stable. So in case of crosswinds, the TPNR remains the same and DPNR reduces. If the headwind changes to tailwind, the distance to PNR will remain the same. Of course, because in case of headwinds and tailwinds, both the distance is reducing. So it doesn't matter if it's headwind or tailwind, the distance will reduce. The constant wind reduces the distance to PNR from still air condition. Yes, because still air condition, it was maximum. Now because of the winds, it has reduced the distance. Distance will vary directly with the endurance, of course. DPNR is equals to E OH upon O plus H, directly related. The carriage of extra fuel. The fuel on board has increased. The distance to PNR increases. I told you when the fuel on board increases, the distance also increases. Obviously, when you're carrying more fuel, you can travel more distance. The distance to CP remains the same, because I told you that CP is a function of winds and PNR is a function of fuel. Next point, any improvement in performance will increase the distance to PNR. Fuel flow decreases, distance to PNR will increase. Fuel flow has reduced, so of course our distance to PNR will increase. We are using less fuel, so our distance will increase. If the fuel carried is only trip fuel plus reserve, trip fuel is reserved, then our safe endurance is equals to flight time. CP and PNR will coincide, which means that the fuel on board is just sufficient for the flight. PNR will usually be beyond PET, yes, like we did in the diagram. Here lies your CP or PET. And as PNR is the maximum distance, it will lie beyond the CP or PET. If the fuel consumption is increased by X%, then the distance to PNR will be decreased by X%. So, as I've told you that when the fuel consumption increases, the DPNR, the distance to PNR decreases. Because more fuel consumed, less distance can travel. So when fuel consumed is by X%, then the distance that will be then the DPNR will be reduced by X% as well. This we are done with our explanation and notes for PNR. In the next video, we will be doing some theory questions and some numerical questions of PNR. Also, I will explain to you how to do those numericals. So I will see you in the next video. Please revise everything before the class, because in today's class also I explained to you PNR with the difference with CP. So please do revise your notes, and in the next class I will see you with the theory and the numerical questions and explanation. So thank you for joining. Have a nice day.